look at some of the trends that we see in the industry, and then how those are applied into some specific industries and the benefits that those trends and the capabilities are providing to those industries. And then we have a short video at the end that will just give a view to some of the capabilities that may exist in the future. So what we see that there are converging forces that are really now placing geospatial information at the heart of an evolving ecosystem. If we look at what's happening around the world and from the capabilities that now exist, whether it's from a technology perspective with all these multiple sensors now capturing data and providing a level of information, the applications that have been built on top of the information that is available that actually start to drive or dig deeper into the domain for a particular user base or for an industry. And then the roles of individuals in those industries, those roles are changing dramatically as we look at how the whole ecosystem is evolving here. And then obviously there's the economics for those industries. What is the return on investment? We're seeing the benefits that are coming into industries, whether it's reduction in rework, the ability to, from the farm, to reduce the amount of input from a fertilizer perspective, or the yields that have been driven from agriculture. There's a significant economic benefit being derived from the world by this ecosystem and the use of geospatial information. And finally, it's society's driving this as well, whether it is through the need in the future from a population mass, from land administration to provide land tenure to people, or from the environmental impacts that are taking place around the world, whether it is in the construction phase, it's from an agriculture, it's from mining, etc. All these elements are coming together in terms of helping this ecosystem to evolve. So what are the real characteristics to helping to drive this change? So one is that we're replacing the traditional ways of doing things with much higher productivity solutions. The ability to capture data in very, very different ways from the way data was captured in the past, are enabling new applications or new ways of applying that data into solving business problems or solving government problems at the same time. We're able to look at how we can migrate away into adjacent areas of buildings or processes can be developed at a far lower cost than they have been in the past. The investment to get in today is far lower than it used to be historically. And then we look at emerging economies, and emerging economies, particularly where maybe they're trying to put in land administration systems, they can actually take a leapfrog from a technology perspective. They haven't got to go through the whole steps that maybe the Western world has gone through over the last 200, 300, 400 years. They can leapfrog to the latest technology, and again, the cost of implementation can be a lot lower than it would have been for establishing it in the more developed world. And finally, it's looking at technology as the enabler. So you've got this integration now of position, of communication, and then the applications, the software that stitches this all together, but then enables applications to sit on top of these platforms to help solve a particular problem for somebody. So if we look at the evolution from spatial data, and I won't go through the whole list here, but just pick out a couple of key things. I think one is now the migration from data from the office to the field. A lot more can be done in the field. That information can be two-way information. We heard that from Aladdin as well, where you're getting that real-time information, real-time decisions can be taken rather than having to wait until the end of the day or the end of a period for the data to be processed. So the real-time element, that dynamic element, is critical to the way operations are run across the world today. I think you also look at the data integrity. So in the past, it used to be all official data, but I think now it's sufficient data to solve the problem we're trying to solve for that particular customer or that particular industry that we're working in. And again, what is that information? How does it need to be provided? What decisions are we trying to make based on that data, based on that information? Now I think you start to look at, on the last one there, in the past it used to be, from a geospatial perspective, it used to be tied primarily to professional people. I think now really it is, the whole influence is changing. It's a whole host of new users out there, a whole host of people who are providing input to the process, and a whole host of different people are now utilizing the information that's coming from that process. And the key thing there is how you interpret the data and to ensure that you're solving the problem, again, that you're trying to solve. So if you look at an enterprise today, and this can be a commercial enterprise, it can be a government organization, but really you see that the geospatial content geospatial information is the heart of that enterprise today. Information can be coming in from multiple sources, it can be being processed, and then a decision can be made based on that information. So that could be coming from, on the top left-hand side there, in a city environment, from the citizens and the consumers using their smart devices. They could be taking pictures, they could be relaying immediate information back into the government offices that this light is broken, there's a pothole in the road, and then you can start to process that data to actually mobilize your field crews almost in real time, or determine the appropriate time to go and solve that problem that the citizens have identified. At the same time, if you're looking on a farm or on a construction site, information can be coming backwards and forwards from the machine. It's not necessarily off an individual human user. The machine's providing information, you're getting that real-time information. If you need to start to make changes in the process, you can do it there and then back in the office as a site manager or the construction manager or the farm manager. That information's coming backwards and forwards. And again, you've got the management dashboard, so looking at that information, what are you going to do with it? What decisions do you need to take? And then acting on them almost in that real-time moment. So again, if you think of any environment now, this is really how we see multiple industries and how operating geospatial information at the heart of those industries. So a laundry list of industries here, but I'm going to touch on three very briefly, just to show how geospatial information is being used in those industries to help make them more efficient and help solve some of their problems. So if we look at the construction industry, this can either be the heavy civil or into doing a building like this. But really, when you look at how geospatial information is being used from the concept on a particular project, right the way through the design, the estimating, into the project planning, into the construction phase, and then into the ongoing operations, geospatial information goes across that whole continuum. But at the same time, you can now start to migrate from taking the model out into the field. You actually have a constructible model where you can take that 3D model, whether it's for a road or an airport, a terminal building, a hotel, and start to take that out into the field, onto the individual subcontractors who are helping to fulfill the construction process. By utilizing that capability, we're now seeing from the machine side, just on using the dozers, graders, etc., there's a 30% productivity gain from the utilization of the machine. Also, we're seeing both from the civil engineering and from the building construction, rework has been reduced by 50% by utilizing that constructible model. And then from an overall project, cost improvements of up to 30%. So significant efficiency is now being brought to the construction industry by applying geospatial capabilities into that industry, but also understanding the needs of the industry, a deep knowledge of the domain to understand the challenges they face and how you solve those challenges. The second one is in agriculture. So a lot of talk around this morning around how we help feed 9 billion people by the year 2050. By employing geospatial information in the agriculture industry, whether it's from precision farming perspective or from applying fertilizer or weed killer and doing it specifically on the individual plant rather than spraying the whole field, again, we're seeing significant input savings to the farmer, but also from you have the environmental benefit of the application of the pesticides and fertilizers, but you also now have a significant reduction in water usage as well. And as we see in many parts of the world where we're facing drought situations, that is critical in terms from an environmental perspective to get those benefits into the agriculture industry. And the third one is looking at transportation and logistics. Again, by utilizing geospatial information, understanding how the trucks are being operated, understanding how the drivers driving those trucks, we're actually seeing reduced operating costs, reduction in fuel costs of up to 20%. And at the same time, the fleet operators have seen an improvement in utilization of approximately 30%. So again, significant gains, efficiency gains being provided into a different industry through utilization of geospatial information. Again, it comes through from understanding, working with the customers, understanding their challenges, and how can the information be applied to solving their respective problems. So what I'd like to do just to wrap up is just show you a short video on looking at, and the question came up on the previous session this morning around augmented reality, etc. So I'd just like to show you a short video that we put together with Microsoft looking at how the HoloLens could be applied in the future.
Literally hundreds of enterprises can be represented on a job site. Today, the best way those companies have to interact with each other is paper drawings. But people aren't good at visualizing 3D.
Microsoft HoloLens is a head-mounted, self-contained computer that lets you see holograms in the real world.
You get the physical model as a focus point for the team to collaborate around. And you get the hologram with the flexibility, with the ability to run quick iterations.
You'll see how we've brought in the courtyard that you suggested. You see that mouse go off the screen and into holographic space, and you're then interacting with the hologram with the mouse.
The thing that we can do for architects is really give them much higher confidence around decision making. One way we can do that is we can allow them to literally immerse themselves in the scene that they're building and see street side how the building's going to look.
Visualizing design data in the context of the real environment is a much better way to make sure that the design is implemented correctly on site.
Microsoft HoloLens allows you to collaborate with somebody regardless of distance, like they were there. Hello there.
Hey Igor, where they're trying to put this door, there's a beam behind here.
I'm looking at this beam. We're interacting with it about a problem that we can see and being able to solve that problem with all the data that we need in front of us in real time.